Hey guys, we're going to do our homework for 8-1. So hopefully you have notes on these pages and make sure you do your lesson check. And our homework starts here on question 10 and it goes through question number 28, kind of skipping around. So let's do it. It says mathematically, I love these questions, very, very cool. What would be the length of this in comparison to the length of that? Okay, so this would be a real life. Let's say you had to mail an umbrella or a bat, or you had to take an umbrella in a suitcase and you have two suitcases, a long and skinny one and kind of a more normal suitcase. Which suitcase would work? And so imagine your umbrella is longer than 15 inches. It's longer than any of these. Maybe it's 17 inches long. Which box will it fit and which one will be the longer? Which one will it fit the best in? Okay, so let's see. This first one, I want you to focus on this bottom triangle because you notice that I need a triangle. Let's see. I need to use Pythagorean Theorem on this triangle. You see what I'm saying? It's living inside that 3D shape. And I know the height of this triangle is 15. The width I don't know, and then I can use Pythagorean Theorem. But notice I could solve for this if I knew the length here. So this triangle I'm isolating in, and that looks like it's not 90 only because I'm trying to give it some depth perception. I can solve for this measurement, and then that will allow me to solve for this long diagonal. And I can do that by this basic idea, right? That's a 3 and that's a 4, so I know that's 5. Now, if you don't know that so I know this is 5, right? If you don't know that for sure, we can double check. Again, 3 squared, 4 squared. What would that hypotenuse be? Notice I add to get 25. So C is the square root of 25, which is 5. Our very famous, most famous 3, 4, 5 triangle. Now using that information, I can solve for the hypotenuse. Okay, so one of the sides is 5, the other side's 15, and this will help me solve for this inner diagonal. So we get 15.8-ish, and they just asked which one's longer. Okay, so right now that won't fit, but we could fit one longer than 15, just not all the way up to 17. Okay, now let's do this one using the same idea. Notice you can see this inner right triangle here inside the box, and to solve for the dimension here, we have a triangle on the base, right? It's this 4, 12, and that is 90, 4, 12, and we can solve for that missing side. So 4 squared, 12 squared. Okay, so the length of this side is the square root of 160. Now I have this other triangle, square root of 160, 9, and I can solve for this missing side. So 9 squared, square root of 160, and my hypotenuse squared. So that would be 241. Oh, so it looks a little smaller. So if I take the square root of 241, that should be smaller than the square root of 250. So 241, take the square root. 15.5. So they're very close to each other, but which one is longer? Prism P is longer. And interestingly enough, an umbrella or a bat 17 inches long would not fit in either one. Next, what did Dakota do wrong? All right, so we had an example like this. This is a square cut in half. These are the sides of the square. So if we know our hypotenuse is 21, we can solve for x. We take the square root of both sides. It's 21 divided by the square root of 2. And that looks a little weird, so we get our magic 1. We get 21 times the square root of 2 all over 2. So this is 21 halves times the square root of 2. This is 21 halves times the square root of 2. And I was able, there is enough information. That's what makes these special. Nice. Okay, what about 15 and 16? This says use example 1. That's when we just used Pythagorean Theorem. So order the sides least to greatest. So 9 squared, don't know b squared. Remember, you have to distribute this square root side. So 5 squared and the square root of 10 squared. So that's 25 and 10. Okay, the square root of 69 is 13. And that number makes sense. What about number 16? This one's a little bit more straightforward. We've got order the sides least to greatest, the hypotenuse always being the longest side. We could figure out what decimal that is. The square root of 269 is 16.4. And that's about right, right? It's longer than the other two sides, 16.4. Cool. Okay, number 20. With a lot of students, we did this in class, so I'll just go over. We said when the hypotenuse is 12, we see this pattern that each side of the square would work backwards. We saw it in our very first example of today. That was 10, and each of these were 5 times the square root of 2. So mimicking that pattern. Here, how did they get this pattern? Well, the longest side is 18. That was like our example where the longest side was 12. That makes the short side 6, and this 6 times the square root of 3. Kind of mimicking that pattern. This should be the length of the other sides. Now, what did we think? Here on this triangle, here's my equilateral cut in half, right? That's 30 and 60. And so now this is this funky pattern that we've seen emerge a couple times. When my altitude of my equilateral triangle is an integer, I get that integer divided by 3 times the square root of 3, and then I double that. That integer doubled. So looking at the other shape, this is a square, which would mean this is also 10 divided by 3 times the square root of 3. So the question asks, what is the whole thing QS? QS would be 10 plus the quantity 10/3 times the square root of 3. Cool. All right, last set of problems. Notice 27, same kind of pattern. We have an equilateral triangle cut in half, so if this was 12, you cut that in half. Ooh, maybe I got this wrong here. Yeah, so this would just be this cut in half. I did get that wrong in class, just trying to go too fast. So this would be 37.4 divided by 2, which is 18.7. And then this would be 18.7 times the square root of 3. Same pattern. If If this is x, this is 2x, and this is x times the square root of 3. Same pattern there. All right, so I skipped one. Let's go back up and get 26 and 28. The kite is flying at the end of a string that is 200 feet long. All right, the wind pulls the kite and the string taut so that the string forms a straight line. The line makes a 65-degree angle with the ground. So this is a straight line, and this is 65 degrees from the ground. About how high above the ground is the kite flying? So we know 2 of the 3 angles, so I'm going to take 180, take away 65, right? Take away 90. So this is close to a 60, 30, 60, 90. Do you see why it's saying about? Why are they asking me to approximate? So if this was 200 and it was exactly, this would be 100, and this would be 100 times the square root of 3. So about how high above the ground? About 100 feet. Just kind of ballpark rough estimating. Why? Because this angle and this angle are close to a 30, 60, 90. All right. Performance task. Emma designed 2 triangular sails for a boat. So this is our square cut in half, right? So this would be 6 times the square root of 2, 6 times the square root of 2. Again, we got this from our first example, noticing our pattern, right? Now here, what would this be? Working from my hypotenuse, this would be 8.7 divided by 3 times the square root of 3. And this would be that doubled. So what is 8.7 times 2? Yeah. 8.7 times 2 is 17.4. So this would be 17.4 divided by 3 times the square root of 3. Right? Now they're asking, what is the area of the sail A? Oh, they didn't even need to. Oh, maybe they did. What is the area? So this is kind of cool. What would be the area? Well, the area of a rectangle or a square is base times height. Well, it's also side times side or side squared because it's a square. So what would be the area of this square? 6 times the square root of 2 times 6 times the square root of 2. So we get, we can rearrange the order of these numbers so that it looks like, we can multiply in any order. So we get 36 times the square root of 4, but the square root of 4 is 2. So our answer is 72. Very interesting. Our answer is 72. Now, what would be the area of sail B? Well, that would be same thing, your base, right, by your altitude. But wait, did I mess something up here? This was a square of that dimension, but then you cut that in half. So I got to make sure before I do my final answer, cut it in half. I should have gotten 36 for my answer. Yes, let's make sure I got 36, not 72. All right, because it is not a square, it is a square cut in half. Now when we look at the sail B, we said, well, what is the area of this? And it's not it's an equilateral, but we'll just look at a regular triangle. That's base times height or altitude divided by 2. So the base is 8.7 divided by 3 times the square root of 3. And the altitude is 8.7. And we want, we could also think of it as 1/2 base times height. So we want this 1/2 somewhere here in our equation. And that's the area of our triangle. So 1/2 base, that was this, right? And height, that was this. Okay? So this is a bunch of gobbledygook in a calculator here. Multiply numerators, so 8.7 times 8.7. So that would be 75.69 times the square root of 3 all over 2 times 3, which is 6. So we can divide by 6. I get 12,612.15 times the square root of 3. So let's go ahead and turn this into a decimal. We're going to multiply by the square root of 3, which is 1.7, and our quantity 12.615. 21.8 units squared. I don't know what our dimension, oh, meters. All right, and that's our other, right? Sail number 2. Is it possible for Emma to cut both sails from one square of sailcloth with sides that are 9 meters long? Draw a diagram to explain. I don't mind if I do. So let's say she had a square of cloth, 9 meters by 9 meters. All right, now what is 6.2 times the square root of 2? So square root of 2 times 6 is 8.48. So this is 8.48. So that's almost this whole distance. So this is my yellow part of my sail. 8.48, almost the whole distance, 8.5. There's not much left. 8.5, and then this is 8.5. So it's only leaving about a half of a meter left. Is it possible? Now you might have to do some sewing, but if I add these two, there will be enough fabric, right? So let's add these two. And the total area would be 57.8. Well, what's the total area of this square? 9 times 9 is 81. So cloth-wise, there's enough fabric. Right? Let's see. What about here? Oh, yeah. I think here we notice with our orange one, right? This altitude is 8.7, excuse me. So that would fit right here, and we've got some fabric left over. So this would be 8.7. And then I would only move over something less than 8.7. And so, yes, there is enough fabric. Nice job. See you next time.